All right, guys, I'm trying to be quiet because people in my house are still asleep. Right? But people have already contacted me about this homework. Not understanding it, so I'm going to try to put it into context for you. Right? Now, think two different equations for the same problem. Right? These equations is this is talking about, they're both talking about the entire population. Right? They're both talking about alleles of an entire population. But this one is talking about outright the alleles themselves, dominant alleles and recessive alleles, right, in the population. And the frequency we're talking about, not raw numbers. All right, if we have like 100 people in the population, I'm not saying 50 people are dominant. I'm asking how often do you come across dominant alleles? Do you come across them 50% of the time, 20% of the time, 100% of the time? We're talking about percents, which we can't do math with. We got to turn them into decimals. We'll get there later. All right. So this is alleles. Right? Alleles in the population. This side is genotypes. Right? Kind of similar, but also kind of different. Right? As evolutionary scientists, as for this homework, we care about this side. But there's a problem with that. We cannot just go to a population and look at people and go, oh, yes, I know what your alleles are. No, because of your genes. I don't know what your genes look like. I can't look at you and tell. I can look at you and tell what your genotypes are if you're recessive, right? So this is the genotypes. You don't remember that word from last chapter? Homozygous dominant, meaning two dominant alleles. Heterozygous, meaning a dominant and a recessive. Remember, P is dominant, Q is recessive, dominant, recessive. And then Q squared is two recessive alleles. Right? Q squared, two recessive alleles. And this is where the trick comes in. As evolutionary scientists, we don't actually care about this side. We care about this side. We want to know what the alleles look like in a population, because evolution is when these numbers change. Right? Mathematically, that is the definition of evolution, when these numbers change. Generation one, they look one way. Next generation, they look different. Next generation, they look different. Right? That's evolution. But we can't see this. We're going to use this to figure out what this says. That's the point. That's why we have two equations. So you can look at a population. First off, your homework. The first one is easy because it outright tells you all three of these. It tells you raw numbers. You have to turn them into frequencies. Just how many of these guys divided by the total population equals the frequency. How many of these guys divided by the total population gives you the frequency. And these guys divided by the total population gives you the frequency. That's easy, right? Then use this to find this. That's in the instructions. The second one is a little bit closer to reality. I'm sorry, that should be your third question, right? Second setup, third question is closer to reality. If we're talking about dominance, well, these guys look dominant. These guys also look dominant. We can't look at a dominant animal and tell which one they are, right? That's useless. But we can look at a recessive and know that they're recessive, because the only way to look recessive is to be this, two recessive alleles. That's it. So anytime you see a recessive trait, it's this one. All right. So here's how you're going to do that third question. You can figure this out from reading it. I don't have the homework in front of me. I don't remember the numbers off the top of my head, but that's fine. You figure this out, right? How many are recessive? Divide that by the total population and gives you the frequency. That's Q squared. We can plug that in over here. Q. Let's find the square root. Square root of Q squared is Q. So the square root of your frequency is Q. Nice and easy. Right? And then P plus whatever that number is equals 1. Right? Subtract both sides by Q. Right? P minus Q is, sorry, 1 minus Q is P. Nice and easy, right? Say it again. 1 minus Q, which you found, is P. Now you have P and Q. You're happy with that. But your question wants to know the rest, so you know P, square it. Now you got P squared. 2PQ, 2 times P times Q. 2 times P times Q. Plug it in a calculator. Right? Here, guys. We just did both problems. Right? Your fourth question just wants you to find P and Q. That's it. And then it's going to ask you, is it in equilibrium? Equilibrium means no evolution happened. So generation 1, you just found. Generation 2, find P and Q, and compare generation 1 to generation 2. If they are the same numbers, equilibrium. If they're different numbers, evolution. That's the difference, all right? Hopefully this helps. If not, contact me. We'll get a Zoom meeting and we'll plug the actual numbers in. Good luck.